This is a video about solving equations when we've got more than one term with a variable. So our first example this time is 5x plus 2 equals 3x plus 10. And we want to solve for x. Now this is very like what we did in the last video. And our instruction is the same. We want to get the like terms on the same sides. So let's just note our like terms in this example. We've got our x terms, 5x and 3x. And we've got our constants, 2 and 10. Now I'm going to put the terms with the variables on the left-hand side and the terms with the constants on the right-hand side. So let's look at the left first of all. What's going to stay on the left? Well, I want the x terms to go on the left, so 5x is already there, so it can stay put. And before I move the 3x, I want to just point out that where it has no sign, which means it's automatically a plus. So it's a plus 3x, and I want to move the whole term across to the far side. So when it moves to the left, it's going to be minus 3x. Now I've got all my x terms on the left. On the right-hand side, what's staying put? Well, the plus 10 was already there, so I'm going to keep it there. I've written down just 10, but we know that if we don't put a sign in front, then it must be a plus. So I can put the plus in, or I can leave it out. Now the 2 must move across, and it was a positive 2 here, it was adding, so it's going to be a minus when it goes over. So now I've grouped all my like terms together correctly, and now I can simplify. Okay, so on the left-hand side, I'm simplifying the x terms. Notice that when I'm putting x terms together like this, when I'm adding and subtracting them, that I am just going to look at their coefficients. So I've got 5 minus 3, that gives me 2. So 5x minus 3x is 2x. On the right-hand side, I've got plus 10 minus 2, that's just going to give me 8. And now it's pretty easy to go from here. I'm just going to get the x term by itself. And like always, once I've just got a coefficient here, I'll just bring it across and divide. So the x stays on the left, the 8 is already on the right, the coefficient 2 comes across and divides. When I evaluate this, I get x equals 4. This is my solution for x. Yeah. Just like in previous videos, I can verify that the solution is correct by substitution. This time, because there's calculation required on both sides of my equation, I'll type in the left-hand side first of all, and I'll get 22. Then I'll type in the right-hand side, and I also get 22. And 22 equals 22, so this statement is true. So x equals 4 is the correct solution for this equation. Okay, let's try a second example. I've got 4x plus 1 equals 11 minus x. Same idea as before, I want to get the like terms on the same sides. Just before I begin, notice here that I appear to have an x term that has no coefficient. So this is my minus x here at the end. What number could I put in front of this x? So I could stick a 1 in front of it. What's the coefficient of this x? It's minus 1. Okay, now that we've established that, let's begin. So I want to get the x's on the left and the constants on the right. Let's have a look. 4x is already on the left. And remember, when I say on the left of the equation, I mean on the left-hand side of the equal sign. Okay, so I want to get the other x term over there as well. Now it's a minus 1x. So if it's a minus 1x over here, when it goes across, it's going to become a plus 1x. Right. Then on the right-hand side, I already have 11. And the plus 1, the constant from the left-hand side, will move over to the right-hand side. And if it was adding here, it's subtracting over here. And now I can simplify. 4x plus 1x, what will that give me? That's 5x. 11 minus 1, what's that going to be? That's 10. And now I want to get the x by itself. So I'll keep the x on the left, the 10 is already on the right, and the coefficient 5 comes across and divides. I can now evaluate this to get my solution for x. So my solution is x equals 2. Again, I can verify it just like before. And again, I'll have to type in the left-hand side and the right-hand side of this equation separately. So 4 times 2 plus 1 is going to come out as 9. 11 minus 1 times 2 is going to come out as 9. And since this statement is obviously true, 9 equals 9, then that means that x equals 2 is a valid solution for this equation. Okay, so here's example number 3. Again, probably not a bad plan at this stage to pause the video, try and do this yourself, and then play and see if you're correct. Okay, so I need to get my like terms on the same sides. X is on the left, constants on the right. On the left-hand side, I already have 9x. 4x is going to come across. Bear in mind, it doesn't have a sign, so it's a positive 4x. So when it comes across, it's minus 4x. Minus 13 is already on the right-hand side. And the minus 3 is going to come over, and it's going to change to a plus 3. Now I'm going to simplify both sides. 9x minus 4x is going to give me 5x. Minus 13 plus 3, and you can use the calculator if you need to, is going to give me minus 10. Now I'll get the x by itself. So x stays on the left, minus 10 is already on the right, and the coefficient 5 comes across and divides. So this time I get a solution of x equals minus 2. And again, just like before, I can verify this. Type in the left-hand side of the equation first, and then the right-hand side. On the left-hand side, we get minus 21. On the right-hand side, I get minus 21. Well, minus 21 is definitely equal to minus 21. So that's definitely a true statement, which means that my solution x equals minus 2 is correct. For example number 4, we're going to do a problem solver. So in my diagram, I have a rectangle. Now, I haven't drawn it particularly well. Can you think, what should I add into this diagram to really clearly indicate that it's a rectangle? Take a moment to copy this diagram into your copy first of all, and then mark in any additional markings that you think should be included. So I've added a few things into my diagram as well. I've indicated that I've got a right angle in the corner. I've indicated that opposite sides are equal in length. And I've indicated that opposite sides are also parallel. Okay, so there's a couple of parts to this question then. The first one is, make an expression to represent the perimeter of this rectangle. The first thing to notice about this particular question is that it's not saying to make an equation, it's saying to make an expression. Now cast your mind back for a second. What is the difference between an expression and an equation? An expression has no equal sign. So that makes sense because I don't know what the perimeter is actually worth. I don't know what it's equal to. But I can make a statement about the perimeter using the information from my diagram. Okay, so how do I get perimeter again? Well, perimeter is the total distance around the outside of my rectangle. So this side is 3x plus 2. This side is 2x plus 3. This side is 3x plus 2. This side is 2x plus 3. So to get the perimeter, I should add all of these together. And I'd like to simplify this expression. So I can simplify quite easily by putting the like terms together. So 3x plus 2x plus 3x plus 2x. What will that give me? That'll give me 10x. And then constants 2 plus 3 plus 2 plus 3 also gives me 10. So the perimeter can be written as 10x plus 10. I'm going to call this P for perimeter. So the perimeter is 10x plus 10. Now I'm going to add a second part to the question. I'm going to say that I've been told the rectangle has a perimeter of 100 centimetres. I want to use this information to make an equation, and I want to solve that equation to find x. Okay, so I've been told the perimeter is 100 centimetres, but I also have an expression for the perimeter. So I've been able to write down the perimeter as 10x plus 10 by adding up my four sides. So this 10x plus 10, this expression for perimeter, must work out as 100 centimetres, because that's the perimeter of the rectangle. So the equation that I can make, so what would it be, do you think? It'll be 10x plus 10 equals 100. Okay, so now I'm going to solve this equation to find x. This will mean getting like terms on the same sides. The only x term that I have is 10x. It'll stay on the left. On the right-hand side, I already have 100. And the 10 will come across from the left-hand side, and it'll be a minus 10. I can simplify on the right-hand side, and my constants come to 90. And then to find x, well, I can leave x on the left. 90 is already on the right, and the coefficient of x will come across and divide. I can evaluate this, and I'll get a solution of 9. I can verify my solution by substituting 9 in for x in this equation. And if I type in the left-hand side of this equation, 10 times 9 plus 10, I get 100 when I press equals. So x equals 9 is the solution for x. Here's one more little extension question. I'm not going to work it out, but I'll ask the question and then I'll give you the answer and see if you can work it out yourself. So the question is, what is the area of that rectangle? Try and figure it out. And I'm going to give the answer, but I'm going to leave a bit of a gap. The answer is 609 centimetres squared. See if you can figure out how I got to that solution. And better again, do it while showing your work.